Hey everyone, we're going to look at number 20 in section 3.9. Find the derivative of y with respect to x if y is this crazy looking function. This is the sine of x raised to the power of 6x cubed minus 9x plus 15. Okay, crazy looking function here. So this we're going to have to use logarithmic differentiation here. And that's a process of using properties of logarithms. I've listed them out here. Properties of logarithms that we know because, again, a logarithm is nothing more than the exponent on the base. So we have that the natural log, or I'm using log base e in all these cases, but this is true for log base anything. The natural log of a times b is the natural log of a plus the natural log of b. And again, that's because when we're multiplying like bases to different powers, we add the powers together. And remember, the logarithms are the powers or the exponents. If we do natural log of a divided by b, we're subtracting the exponents, right? Natural log of a minus natural log of b. And natural log of a to the n is n times the natural log of a, because when we're raising it exponent to an exponent, we multiply the exponents. So number 3 is actually what we're going to use in this one only. We're not going to use the other two. But again, if you're using logarithmic differentiation, these are the properties you're using to simplify the expression, basically the function, so that we can then take the derivative. So let's see how that works. I take the natural log of both sides of this equation. And then by property 3, I have the natural log of sine of x to this power. So this is like a is the sine of x and n is this power. I'm going to bring this power down in front, right? So I can do that by this third property. And now this is helpful because now I've turned this problem where I had some function raised to another function into some function times another function. So when I now take the derivative with respect to x of both sides, I can do that. Over here, the derivative natural log of y, right? Just remember, derivative with respect to x of natural log of u by the chain rule is u prime over u, or 1 over y. In this case, y is the inner function times dy dx. And I just use that notation because that's what they use in the problem. You could also use y prime. And that's what we're looking for. So that there's the chain rule basically here. And then here I have to use product rule, right? So I take the derivative with respect to x of this thing times the natural log of sine of x plus the first function times the derivative with respect to x of the natural log of sine of x. This one's easy, right? The derivative of a polynomial is easy. 6x cubed is 18x squared. Negative 9x is negative 9. And then over here, I'm going to use this, right? U is sine of x. This is the natural log of u. So the derivative is u prime over u. Well, if u is sine of x, what's u prime? Cosine of x over u, which is sine of x. So I get cosine of x over sine of x. And that should lead you to say, hey, I know what that is, right? That is cotangent x. And that's a much simpler way of writing that fraction. So I'm going to do that. So notice to solve for dy dx, I've multiplied both sides by y. And now I want to express this in terms of x. And so what is y? I'm just going to go all the way back here and just recopy all this stuff. Replace y with all that stuff, sine of x to that power, there's y, times, and then cleaning this up, this is what we have. So again, here's the derivative, not a whole lot more you can do to simplify a big ugly mess, but that's typical of logarithmic differentiation. We have a pretty bad looking function to find the derivative of. Okay, I hope this is helpful on this one for you. Let me know.